Solving rational equations. Solving rational equations can be done both algebraically and graphically. If we're doing this algebraically, what we want to do is we want to clear the fraction by multiplying all the terms of the equation by the lowest common denominator, or the least common multiple. Then we have to set everything to one side, make the other side equal to 0, and solve. The last thing that we need to check is that the solutions are not part of the restriction. So a solution cannot cause the denominator to equal to 0. When we solve equations graphically, we just look for the points of intersections between the two functions. So the first question is actually quite easy. You have x minus 2 over 2x to the power of 7 plus 3x to the power of 4 minus 2x plus 3, all equal to 0. And the key thing to understand or remember here is that a fraction equals 0 when the numerator equals 0. Okay, recall that if a fraction's denominator is 0, then we have an undefined number. So for a fraction to equal to 0, the numerator has to equal to 0. So we actually check right here. We say, okay, so therefore, x minus 2 is equal to 0, and x is equal to 2. Perfect. All right. One quick check that we can do is we can sub 2 into the denominator, and we'll find that this does not produce 0 in the denominator, so this is an okay solution. Looking at the next question right here, I have x minus 2 over x plus 1 is equal to x plus 3 over x minus 4. The first thing I'm going to do is state the restrictions. X can't be equal to negative 1 or equal to 4. So I have to remember that when I find my final answers. The lowest common denominator between these two fractions is x plus 1 times x minus 4. Okay. Often, if you really want to find a common denominator quite quickly, you just multiply the two denominators together. So x plus 1 times x minus 4, that's the lowest common denominator. I'm going to take this and I'm going to multiply it by both sides. Right? So x plus 1 times x minus 4, then times x minus 2 over x plus 1, x plus 3 over x minus 4 times x plus 1, x minus 4. What this effectively allows me to do is it allows me to clear the fractions. And so I no longer have to work with fractions. I can work with basically two binomials multiplied on the left side and two binomials multiplied on the right side. This is a little easier to work with. I can just expand this now, and so this is basically x squared minus 6x plus 8 is equal to x squared plus 4x plus 3, bringing everything over to the left side. Okay, I'll write x squared minus x squared minus 6x minus 4x plus 8 minus 3 is equal to 0. Okay, noticing that the x squareds and the x squareds cancel, I end up with a simplified version of this equation, which is negative 10x plus 5x, or sorry, plus 5 is equal to 0, and then bringing the 5 over, negative 10x is equal to negative 5, x is equal to negative 5 over negative 10, so x is equal to 1/2. I check my solution here. So x is equal to 1/2 is the value of x that makes this equation true, but I have to check that 1/2 is not part of my restrictions. It's not. My restrictions were x can't be negative 1 and positive 4, so therefore this is the correct answer for that question. In the final example, you can always solve a rational equation by graphing the two functions. So I'm just going to color code this for you. You can graph the red function right there, 1 over x plus 3, and then graph the blue function, 2x plus 1 over x plus 4. The points of intersection are the solutions, right? Recognizing here that, you know, x can't be equal to 3 or x can't be equal to 0. The solutions for this question are x is equal to negative 2.823 and x is equal to negative 0.177. So we just look at the x values at the point of intersection. And those right there are the solutions to this rational equation. Homework is listed right here. There's some extra practice questions here on a handout. Thank you for watching.